Hello 2021, it's really been a long vacation and we are back into C programming. So today we are going to see the basic types and variables in C. Without further ado, let's get started, right? Previously we saw how a C program is made up of statements, right? These statements are just action that acts upon data to produce a specific result or a specific value. Right now in your program, we have two kind of data. Okay, the first kind of data we are going to see is known as a literal. These are data which are known at the time of writing your program. For example, you can set its value at the time you write your program. Let's say int age is equals to 24. This is known as a literal. Okay, we also have another type of data which is known as dynamic. Now in this kind of data, we don't know the value unless you run your program. Usually this kind of data comes from calculation within your program or from input through your input output function. So for example, here you can say int age without setting the value. Okay, now the value of age is not known at the time of writing your program, and this value is dynamic because it changes each time you run your program. Age could be 2, age could be 10, age could be 24, age could be 42, right? So this data is dynamic, meanwhile this one is fixed throughout your program. Now let's talk a little bit about number system. A numeral system is a conventional way to express number. Okay, for example, in computing we have 4 basic numeral system. We have decimal, the one we use every day. We have decimal, hexadecimal, octal, and binary. To represent this numeral system, we use a positional notation. Assuming we have a number n, to represent it as a numeral system, we are going to say n. We are going to say the first digit of n multiplied by the base, be it the decimal, hexadecimal, octal, or binary, raised to the power let's say here 0, plus the second digit times the base raised to the power of 1, plus the third digit times the base raised to the power 2, and so on. The notation I have used here implies that the most significant digit is at the right, meanwhile the least significant digit is at the left, but usually this is not the case. Assuming, for example, we want to represent a number x, y, our base is b. So what are we going to do? We are going to place position starting from 0 and moving to your left. So z is going to be 0, y is going to be 1, and x is going to be 2. Yeah, this simply implies that the most significant value is x and the least significant value. So to represent this xyz in base b is going to be x times b raised to the power 2. So that is how you represent a numeral system using a positional notation. But what you have to know about this position is it starts from 0 right up to the position minus 1, because we start counting from 0 and we don't start counting from 1. So we start counting from 0 right up to p minus 1, right up to the last position minus 1. So let's have a review of the 4 numeral system we have in computing. Decimal means base 10, that is we start counting from 0 up to 9 and it has 10 digits. Now for example, let us express this number 1, 2, 3 in decimal. It just simply means we put our index here, our position here. We start from 0, 1, and 2. So to represent this number in decimal, we just say 1 times 10 raised to the power 2 plus 2 times 10 raised to the power 1 plus 3 times 10 raised to the power 0. Now we have to know one thing in maths, that is anything, for example, a raised to the power 0 is equals to 1. In this case, 10 raised to the power 0 is 1, so it will be 3 times 1, and 10 raised to the power 10 is 1, that will be 2 times 10, and we have 100 here, that will be 1 times 100. Now if you want to place this number, we will place like 100 here, 20, and we have here 3. So if we sum this number, it's going to give us 1, 2, 3 in base 10. Okay, in hexadecimal system, the base is 16, that is we have 16 digits ranging from 0 right up to 9, and from A right up to F. So if you count from 0 right up to 9, we have 10, and from A right up to F, we have how many? We have 6. So in total we have 16 digits to represent a hexadecimal system. Present 7EFF in base 16. We will start by putting our position. We have 0, 1, 2, and 3 here. So in this case it will be 7 times 16 raised to the power 3 plus e. So based on this logic here, we notice that a is going to be 10, and b is going to be 11, c is going to be 12, e is going to be 13, d is going to be 14, and f is going to be 15. So using this logic here, e is going to be 13, right, times 16 raised to the power 2 plus f. We notice here f is 15 times 16 raised to the power 1, and 10 raised times 6, 16 raised to the power 0. Okay, so if you sum up this number, you will have 32511. This number is represented in base 10, right? It's a decimal representation of 7EFF. Okay, so this number now is in base 10, and this one is in base 16. Okay, octal simply means base 8, right? It ranges from 0 right up to 7. Assuming we want to represent this octal number 7761 in decimal, what we are going to do is we will say place our position value as you know the drill. 7 times 8 raised to the power 0. Now if you sum this number, I think you will have 4081. Now this is the decimal representation of, here is in base 10, 7761 is in base 8. So this is a decimal representation of 7761 in base 8. Okay, so binary simply means base 2, that is 0 and 1. From a computer's perspective, data is represented as a series of 1 and 0. Now let us see an example of a binary number in which can be represented in a decimal. So let's have 1101 in base 2. Now let us represent it in decimal. So you all know the drill. We do the same thing, 0, 1. The actual representation of this number in decimal is 13. So let me talk about how we can represent the fractional part of a number. For example, assuming we have 0.101 in base 2. So how can we represent this number in base 10? Now for fractional part, you start counting from -1 and you increase in the negative direction. So the next number will be -2, the next number will be -3. So in this case here, number is represented in base 2. So in this case it's going to be 0.1, right, times 2 raised to the power -1 plus that, we forget about that one, plus 1 times 2 raised to the power, here will be -2, here will be -3. So we forget about this one since this is 0, plus 1 times 2 raised to the power -3. Now if we sum all this, it's going to be equivalent to 0.625 in decimal. Let's talk a little bit about data representation in C. As a C programmer, you don't really need to know how data is being represented by the hardware, but the reason why I'm talking a little bit about data representation is just for you to have a perfect understanding about the type C provides. The basic type in C programming is laid out in 2 types, that is the int and we have the float. Okay, these are the 2 basic types in your program. Why is it different? This is just different because of the representation. Now the way the computer represents an integer and the way a computer represents a float is different. They are not equal. Okay, so your data is either laid out as an int or it is either laid out as a float. Let's talk about how your computer memory is being laid out. So your computer memory is being broken down into pieces of chunk. Assuming this is your memory, which is being laid out into small pieces of chunk, right, and it's been assigned to its index. Right, here we have an index, and this index is also known as the address in which you use to access this chunk, this piece of memory. Now depending on the architecture of your processor, right, this chunk of memory could be 6 bits, it could be 8 bits for modern computer, it could also be 32 bit, okay, it could also be 13 bits that make up this one piece of memory. A computer program don't access bit, okay, it access like one chunk of a memory, and this one chunk of a memory is known as your byte. Okay, now again, depending on your architecture, a byte could be 6 bits, right, a byte could be 8 bit for modern computer. But now let us assume in our computer the architecture is being designed so that a byte is made up of 8 bits, and modern computer can directly access a group of bytes. For example, you can group this byte together and your program or your computer can have direct access into this group of byte. Now the address of a group of byte is the address of the byte that has the lowest address. This is known as the base address. To know the size of bytes of your computer, all right, you use this macro char bit, okay, which is being found under your under this header limit.h. Now let us talk a little bit about engine. Let us consider a number 29377826261. Okay, in hexadecimal form, this number is represented as AF. This number is represented using 4 bytes of data in your computer's memory. So Engineers tries to explain to us how a number is being represented in your computer memory, right? This one is from the perspective of your computer, which you don't really have to bother. So in your computer memory, how do you think this number in decimal, which is being represented in hexadecimal here, how do you think the computer will read this number? One way to read this number is either from left to right or from right to left. Now if we are reading this number from left to right, it's going to be represented as AF 1B 015B, right? And if it is being read from right to left, it's going to be 5B 0. In this case, which is being represented from left to right, the most significant bit here is A and the least significant bit here is B, right? So from a computer perspective, it is either the most significant bit, right, that is AF, is being stored at the lowest address of the computer's memory, that is going to be AF, and here will be 1B and 0 1 and 5B, right? Or the least significant bit is being stored at the lowest computer address, that would be 5B 0 1 1B and AF, right? Now this is from the computer's perspective, right? So do not be confused with the way a value is internally represented with the way we write numbers in C. The way we write numbers in C is the same way we write number in our day-to-day life. We start writing number that is from left to right, 1 2 3, and the way number is being represented on the computer's perspective is different from the way we write number in C. Okay, so the way we write number in C is the same way we write number in our day-to-day life. Printing literals in C. So the literals we have in C are integer constant, we have floating point. So to represent hexadecimal number in our C program, we put OX and we put our hexadecimal number. For example, we can put FE, right? This is how hexadecimal number be represented in C. For example, you can put int A, right, equals to OX FE, right? And for decimal, as you all know, decimal is very easy. You just put int A and you put your decimal value. It could be 10, it could be anything. Then if you want to print a hexadecimal number as an integer, you will specify a %d or a %I. We are going to see this later. And if you want to print an octal number, you specify a %O. If you want to print a hexadecimal number, you put a %x, right, or a %X now for uppercase. Now if you want to represent an octal number in C, you put a 0 in front of the number. Okay, this simply means it is an octal number. And for example, we can put int A is equals to O20. Okay, this is an octal number in C, and to print this we use the percentage O. And if you want to print the same number in integer, as an integer you put an I, sorry, as a decimal you put an I, or %G, you all know the drill. And if you want to print a character in C is being declared by using a char. A char in C is being declared by using a single quote. Okay, for example, the character A is being declared like this, and you have to use the data type char, which we'll see a little bit in the future, and we represent our A like this. If you want to print this, you have to use this specifier %C. Now remember I told you that and I will keep reminding you that the two basic type we have in C is integer and floats, right? So in this case, a character is just an integer, right? So you can still define, you still want to print the number representing A as an integer by specifying a %d. Okay, this is a string literal in C. Okay, and if you want to print this, you have to use the specifier %s. For a floating point, we have two notations to represent a floating point. We have a simplified view, and we have a scientific. In its simplest form, a floating point is composed of two groups of digits which is separated by a decimal point. For example, we can have 1.718, which is separated by is composed of two group of digits which is separated by a radix or a decimal point, right? And meanwhile, in a scientific notation, is being followed by an exponent, okay, and the exponent e is in base 10. So for example, we can represent this number, we can represent it in using scientific notation as 1718 e raised to the power -3, but there is no raised to the power here, so it can be represented like this. Okay, so this is how this number is being represented in a scientific notation. Now, to specify a scientific notation on in the printf function, we specify it by using the %e or the big E for uppercase. One thing that which has been introduced in C99 is that we can also represent a hexadecimal number as a scientific notation in floating point. For example, assuming you want to represent this number 5.25 in hexadecimal floating point P2. Now this P, it simply means base 2. So to represent this number in decimal is 1 plus 5 times 16 raised to the power -1 here, or that times 2 raised to the power 2. If you sort this out, it's going to give you 5.25. okay, I don't really think we will ever use a hexadecimal scientific floating point notation in this class. I don't think we will ever use it. Okay, this one is just for demonstration purpose. Okay, now we can also specify a floating point in the printf function using a %g. Now in this case, using a %g, it is either using %e or %f. Now remember, if we are using f is just the simplest form, right? And using g is the scientific form. So depending on the value which is being represented, the compiler will choose to either represent it either in %e or in %f. We are going to see this a little bit later in the course. How are we going to specify this number using the printf? To specify this number using the printf, we write our printf function like this. To specify it, we use the %a or the big A, right? The percentage, we put our number 5.25. okay, so the output of this function should be ox 1.52p. good. So this simply means this is a floating point, right, in decimal notation, right, and we want to print it in a hexadecimal. We want to print this floating point using a hexadecimal scientific notation. Let me talk a little bit about width and how you can arrange your output using printf. For example, assuming you want to space out your printf output, so what you have to do is you have to use some constant value, for example 1, 2, depending on you in your specifier. So in this case, we want to print a decimal number. We put a %g, but instead of putting a %g, let us put the number 4, right? Print the number 4. So the printf is going to space out your output. In other words, it's going to align your output in a nice looking way. Okay, so we put 4 and we can put your value. Okay, so this one is known as the width. Okay, now if you put 4, it will be on the left, and if you put a negative sign, it's going to be the left, the right and the left. And also for a floating point number, you can also specify the width. Okay, for example, you want a value which is 4 and 4 the width, and you want 2 decimal places, and you can put an f. And in this case, assuming we want to print this number, we want to print 3.2567. what do you think the output? I don't know, I keep using this 3.25. yeah, in this case you can see the spacing, but if you put something like a braces here, right, you are going to see maybe a space in here. Okay. So let us talk a little bit about character literals. We already see that to specify a character literal in your printf function, use this %c, right, telling the printf that the number you want to print is a character, and a character is being noted using a single quotation mark. Okay, so within your printf function, this is how you print a character. Now in C programming, we have not printable characters. So for example, assuming we have a vertical tab, we have a form fit, we want the computer to ring a bell, so we display a non-printable character in C by using an escape sequence, which is denoted by a backslash, and for example we want a new line, backslash is for new line. So these are all non-printable characters. Okay, these characters cannot be printable, and to display a non-printable character in your program, use an escape sequence. Okay, so these are special characters which are not printed but have effects when they are output. Another use of the escape sequence is assuming we want our printf function to display the double quotation. We all know that in the printf function, within anything within a quotation mark is a string, right? This tells the printf function that at the beginning of this quotation mark, anything within here, ending here is a string, and prints everything here as a string. Now assuming you want to print a quotation mark within your string, so how are you going to do? You are going to use an escape. We are going to use an escape sequence, right? This escape sequence is telling the printf function that it should remove the special meaning of this double quotation mark. So in this case of printf, if I write printf, right, and I put blah 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 blah, and I put an escape this, and I end my function, and I end my function here. This backslash, this backslash is an escape sequence telling the printf function that remove the special meaning of this, because in this case here the printf will notice that at the beginning of this double quotation mark is a string, and when I reach this one is the end of a string, but in this case the escape sequence remove the special meaning. Yeah, so that is another useful aspect of an escape sequence. Now we are going to see another example of an escape sequence. Assuming you want to display all the ASCII character using octal or unique or hexadecimal, so how can you do this using printf? Now in printf, what you can do is follow 3 octal digit. For example, A is represented as 101 in octal, and in hexadecimal it is represented as 41. So to represent this, we put an escape sequence, and we put x. This x means is for hexadecimal notation, and an escape sequence we put a 3 digit, right? A 3 digit. Now if the number is not up to a 3 digit, you have to add 0 in front so that the number should be up to a 3 digit. Okay, in this case, if we run this printf function, is going to display to us the character A. Is going to display to us the character A in octal. Here is in octal, and here is in hexadecimal. Yeah, this is another useful case of the escape sequence. Okay, so as previous, like I said before, if the character is not up to, for example in octal, if the character is not up to a 3 digit, if the character is not up to it, you have to enforce the printf function so that this character should be a 3 digit. So how do you do that? You put a percentage, right, and you put 0 in front, right, and you put 3, then you put your octal number. So what's the octal? You put your octal specifier, and you put the number you want to display, the digit you want to display. In this case, let us say for example shebang character, for example in hexadecimal is 41, but you notice here that this character is just 2 digit, right? So this specifier here actually is enforcing that if this character is not up to 3 digit, you should add 0. Okay, and if the character is up to 3 digit, no need to add 0. So here you are enforcing the printf function to print 3 character in hexadecimal, 3 digits in octal. So it prints 3 digits in octal. Yeah, so this video is actually very long, and that is it for the basic of types and variable. Actually this is part 1 because this video is actually getting long. This is part 1, and tomorrow we are going to see part 2 of this video, and also there will be a part 3. In our next video we are going to talk about variable. We will start talking about variables and integers now. So I hope this video was very informative, and if you like this, subscribe and share and comment on any question or anything I didn't explain well. Thank you, and I'll see you next time.